Hello everyone, my name is Rojan Singh. We are from Group 3 and here are my groupmates who are Nurul Najeha, Alia Zafira, Anas, Lee and Goyong Hao. Today we'll be presenting and discussing about our project of wireless power transfer system.
Assalamualaikum. We are from Group 3. So our experiment about wireless power transfer system. So for introduction, what is wireless power transfer? Wireless power transfer can transmit electrical energy without physical connector, relying on electromagnetic induction. So in this experiment, we use copper coil and transistor to construct transmitter and receiver circuit. The transmitter generates time-varying magnetic field induced an EMF in receiver coil as described by Faraday's law of induction. This induced voltage is then used to power LED wirelessly.
So our objective for the experiment is to demonstrate the principle of wireless transfer with the use of electromagnetic induction. Our component list is copper coil, LEDs, transistor, the two N222A, 22K resistor, battery, and the breadboard.
Hello, my name is Goyong Hao. I will try to explain the working principle and explanations for the wireless power transfer system. This transmitter, as shown in the diagram, consists of a transformer winding or copper wire winding of 30 turns connected to the transistor, resistor, and power supply. The base of the transistor is connected with a resistor and connected to the one end of the copper winding, and the other end, the collector, is connected to the another end of the copper winding. There's a loop that acts as a center tap transformer that is soldered on and connected to the power supply, the 9 volt, the positive 9 volt. The emitter of the transistor is connected to the ground, as shown in the diagram. Now for the working principle, the transistor, when it is connected like that, it will switch on and off rapidly. Therefore, there is a pulse DC current that is produced that acts as a AC current that flows in the copper windings, and this AC current creates an oscillating magnetic field. This oscillating magnetic field has a high rate of change of magnetic flux that will induce EMF into the receiver part. I should mention that the resistor limits the current flow to prevent overheating. This is quite important because the 9 volt VCC is quite powerful and need to protect the circuit and protect the transistor from burning. The receiver, from before, the magnetic field that is produced, the oscillating magnetic field that is produced by the transmitter, is used to induce the receiver due to the mutual inductance, and hence the receiver will produce a EMF voltage based on Faraday's law of induction. With this EMF, it will light up the LED. Hence, there is power that is transferred to receiver wirelessly. Therefore, from transmitter and receiver pair that is contracted just like that, we can produce a wireless power transfer system.
Now I'll be explaining about some of the electromagnetic formula that are related to our project. Faraday's law of induction states that electromotive force is induced due to the presence of changing flux linkage within some period of time. The flux linkage is also equals to the number of turns of coil times with the magnetic flux. Faraday's law has occurred in our experiment at the receiver of wireless power transmission. Whenever there is a change in magnetic flux that occurs from the transmitter, an induced electromotive force will be produced at the receiver if we put both coils close together, thus powering the LED. So if we sub the flux linkage equation into the Faraday's law formula, we can obtain that the greater the number of turns of the coils will result in a greater EMF. Also, the greater the rate of change of magnetic flux will produce a higher EMF at the receiver. Other than that, Ampere's circuit law states that the close integration of magnetic field intensity dot product with the imaginary loop is equal to the amount of current that exists inside the loop. Ampere's law relates the integrated magnetic field around a closed loop to the electric current passing through the coil. Last but not least, if you want to determine the magnetic flux that produced by the transmitter, we can perform the integration of the dot product between magnetic flux density and the differential area that the magnetic field line passes through. Hence, magnetic flux is defined as the number of magnetic field lines that passes through a given closed surface.
Assalamualaikum. My name is Alia Zafira. So today I will explain now on more applications of wireless power transfer. So this system can be used worldwide actually. Such as the first thing as you can see here is electronic. We have electronic wireless phone charger. Nowadays, people usually just use wireless charger because it's a lot easier, no need cables and so on. Other than that is flow lighting. This mostly used in modern house designs because it's a lot more simpler and more aesthetic look. Other applications can be used in biomedicals. Here we have is a brain machine interface. So this is usually used for experiments, and also the neural recording system is used to usually, as you can see here, is used on animals. Other application here is we have automobile. So it's mostly in electric vehicles chargers, EV cars. And for industry, it is used in instrumented wheel set for rail car actually. And we also have other applications such as in aerospace. We have the wireless sensor network, which is Wi-Fi. We also have magnetic film communication systems such as Bluetooth, and also last but not least, which is frequently used in our technologies nowadays, which is radio frequency identification, also known as RFID. That's it for me. Thank you.
So, in conclusion, this experiment show how we can transfer power wirelessly using electromagnetic induction by creating a magnetic field with a transmitter coil and receiving it with receiver coil. We successfully power an LED without wires. This simple setup demonstrates the basic principle of wireless power transfer, highlighting how energy can be sent over short distance. It provides a practical understanding on how wireless energy system can work in real life application. That's all from us. Thank you.